Support vector machines have been the hottest machine learning model for long. Now they have somehow lost terrain against gradient boosting, but we will come to that later. Support vector machines are maximum margin classifiers. That means that a support vector machine will always get the ideal separation hyperplane between point clouds. So initially, a support vector machine is a classifier, and it's a binary classifier. So here you see H3 is the best separation hyperplane between the 2 point clouds, and that's something the support vector machine automatically computes. As you might have noticed, a hyperplane is a linear separation. So in order to turn a support vector machine into a nonlinear classifier, you can use the so-called kernel trick. So you can transform your training data using a so-called kernel into another space, the so-called feature space. On the left-hand side, in the input space X, you definitely can't draw a line of separation between the two types of points. But once you have transformed those into another feature space, you can. Here I'll give you another intuitive example. So the inner circle has to be separated from the outer one. Definitely not a linear function. But now let's use a kernel, a transfer function, which transforms this 2D space into a 3D space. Let's use the following function. So we take x1 and x2, and as output, we output x1 and x2, but in addition, the third dimension is now x1 squared plus x2 squared. So this looks like the following. So we are basically pumping up the points in the outer circle. And now we can draw a hyperplane between those points, and we have a separation. This image is another illustration which I found. Note that in this case there are no outliers, so we have a clear separation. But a support vector machine is also resistant to outliers. This means we get also a clear boundary between the point clouds, even if there are outliers. The optimization objective of a support vector machine is convex. That's a really cool feature because we are guaranteed that when optimizing over the cost function of a support vector machine, we will always end up in the global minima. But now we have a problem. A support vector machine is a binary classifier. What can we do to turn a support vector machine into a multi-class classifier? This is pretty straightforward. So let's consider this training data with different classes. So now we just take one class and then we assign another class to all the other examples. And we do this for each and every class. And finally we will end up with the so-called one versus all classifier, where we just take one class versus the others n times, and then we output the one with the best score. So in summary, we have learned that a support vector machine is a binary linear classifier. It always finds the best hyperplane of separation because of the convex nature of the optimization objective. We can turn a support vector machine into a nonlinear model using kernels, and we can turn the support vector machine into a multi-class classifier using the one versus all approach.